Hello everyone, today we're going to look at usaco-training the Tamworth 2. Okay, so in this problem we're given a 10 by 10 grid, which each cell can either contain an obstacle, denoted by an asterisk, a cows, or the cows, which is denoted as C, or Farmer John. Okay, and if there's a dot, then it means that it's empty. Okay, so then, basically, F, this position is Farmer John's original or starting position, while this position is the cow's starting position. Okay, so basically every minute they're going to move 1 unit in the direction that they're facing. And in the beginning, both Farmer John and the cows are facing up. So let's just say that they move, or let's just say that Farmer John moved up to here. Then, since there's no cell above, then he would make a 90-degree rotation, and that would count as his move for that specific minute. And also, if they reach an obstacle, they would also turn as well. Okay, so basically, we're supposed to calculate the number of minutes until the cows and Farmer John meet. And they meet if they occupy the same position. Otherwise, we just print 0 if they would never meet. Okay. So this problem has a 10 by 10 grid. So that's pretty small. So we can basically simulate the process of the movement. So we can call a state. Okay. So state, we should store Farmer John's position, Farmer John's direction, and the cow's position and cow direction. Okay, so originally we're given the farmer's position, and we're also given the cow's position, and their direction originally is always north. Okay, so then we basically just simulate, keep on moving these, or keep on updating this state until the farmer position is equal to the cow position. Okay. So then, how do we detect that, let's just say, they would never meet? Because then it would go on infinitely. What we can do is that we can store, every time we visit this state, we can store this state as visited. So next time we reach this, we know that there's basically a cycle, since they're moving in a circle. So then we can break it up into some casework. So let's just say right now we have FP, which is position, FD, cow P, and cow D. Okay, so you know that we can calculate the next farmer position separately from the next cow position. Okay, so let's break it up into, let's just say, farmer. Okay, we know that if we move, then our next position would be FP dot X plus basically the direction, and it would be FP dot Y plus FD, or the direction. So then we know that this is our next one. So if this is not valid, then we know that we have to make a turn. So basically, if that is not valid, we just our move for this minute would just to be incrementing our, or just changing our direction. Otherwise, we just set our position to this. We just set FP to whatever we have above. Okay, so that's for the farmer, and since the cows also move like the farmer, so we basically do the same thing for the cows. Okay, so that's basically it. Oh yeah, so one more thing. So this would run, let's calculate the maximum numbers of states that we would visit. Okay, so we know that it's a 10 by 10 grid. So we know that there's 100 positions because 10 times 10. So we have 100 positions for the farmer and 100 positions for the cows. And we have 4 possible directions for the farmer and 4 possible directions for the cows. So notice that this is pretty small since this is the multiplied would be this, and this would fit in our complexity. So let's get coding. Okay, so let me just copy the name. Okay, so let's include bits. Okay, so you know that you have your grid, so let's call this a string, a grid. Okay, so we know that our n is always 10, so we can make it a constant. So constant int n would be equal to 10. So then over here, we would just do n instead. Okay, so I equals 0. We're just going to read this grid, so just cn grid of I. Okay, so then after this, we're going to basically decode where the cows or the cow position and the farmer position. So what we can do is that we can store a position as a pair of integers. So then we can do pair, let's call this cow and farmer. Okay. So now we can basically loop through each character of the string. So if grid of ij, if it's a cow, then we know that c is equal to ij. So otherwise, if grid of ij, if it's equal to f, meaning that the farmer starts over here, it would also be equal to ij. Okay. So now we can actually make a state. So we can call this a structure state. Okay. So we have our cow position. So we have this, or farmer position. So we have FP. Okay. And then we also have CP, which is the cow position. Now we have the farmer direction and cow direction. Okay, so that's our state. So we have to make a new state. So state, let's call this S, would be equal to basically F, which is the farmer's position, C, the cow position, and let's just call 0 north. Okay, so they're both going to face north. So now we can basically make our like transitions. So what we can do is that we can have an X, meaning the change of the rows. Okay, and we can also have our Y, which means our change in our columns. So we know that 0 is north, so then for 0, to go north, you would basically move up, meaning that your row would decrease while your column would stay the same. Okay, so let's just say we moved 90 degrees or we rotated 90 degrees. So then this would be moving to the right, and since moving to the right is moving one column to the right, so then this would be 1 and 0. And this would be 1 and 0, whoops, and the last one would be 0 and -1. Okay, so basically we want to do this while s dot fp, so the farm position is not equal to s dot cp, which is the cow position. Okay, so basically we're going to try to make our transitions. Okay, so let's call this next farmer. Okay, so next farmer should be equal to as I said before, it should be equal to s dot fp dot x, or we should actually, okay, so let's actually, since we use first and second, we can actually define x as first, y as second. So then we can use this dot x plus the change in x of s dot farmer direction and s dot farmer position dot y plus y of s dot fd. Okay. So now you know that this is our position. So now we need to check if this position is valid or not. So let's make a function. So let's call this valid. It should take in a position, so pix. Okay, so if let's actually call this pi big X or pip. Okay, so if pi the x, if it's greater than or equal to 0, and we're checking the position if it's out of bounds or not. So then or we can do if this is less than 0, or this is greater than or equal to 10, we can return false since this is out of bounds. And we can also try it for the columns. So again, we would return false. So our last case is if grid of p.x, p.y, if it's equal to an obstacle, then we also return false. Otherwise, we just return true. Okay. So now, if this position is not valid, then we just change our direction. So then basically s dot f p or fd actually will be equal to s dot fd plus 1 mod 4. So this is just rotating it by 90 degrees. Otherwise, s dot fp would be equal to next farmer. Okay. So there you go. That is our farmer. So now we're going to do it for our cows. So we actually do it similarly since they move the same way. So we can do pi next cow will be equal to s dot f cow, or no, it's cow position dot x plus x of s dot cow direction, s dot cow position dot y plus y of s dot cow direction. So again, if this is not valid, then we just change the direction. Okay, so otherwise we just set the cow position to your next cow position. Okay. So now we need to check if this results in a cycle. So if they never meet. So we can actually have a map of a state, and there should be a bool. We call this visited. Okay. So basically, if this state has not, or if this state has been visited, then we can just break, knowing that this won't work out. Otherwise, we just set the state as visited. Okay. So now we just need to count the number of moves until they intersect, or until they go to the same position. So let's call this distance. It should be 0 by default. So every time we move, at the end, we're just going to increase our distance. Okay. So at the end, if those two positions are not equal, then we just print 0. Otherwise, we print distance. Okay, so let's actually run this. Okay, so this is usaco-training, and this is the Tamworth 2. Okay, so let me get the input. Okay. Okay, so I guess there's some errors. Okay, state is not derived from Okay, so I guess a map actually stores or actually just sorts this. So what we can do is that we can just change this to an unordered map. And I think we also have to include this. Okay, so an ordered map is not ordered as the name says, so then it would not sort it, so there's no need to sort it. Okay. Well, I guess we can't use an ordered map, so we can actually just use an array. So this may not be the best solution, but it is a solution. So we can do int visited. So the first position, second position. Again, this is for the cows, and then we have our direction as well. So then over here, instead of doing this, we would do if visited of s.fp.x, s.fp.y, s.cow position.x, s.cow position.y, s.farmer direction, s.cow direction. Okay, we just break. Otherwise, we set this really long thing to true. Okay, so that worked. And 49, so that looks correct. I'm just going to submit it to the grader. So this is 2.in, and writing to 2.out. Okay. So let's actually put in the information. Okay. So here. Okay, it's loading. Okay, so this is usaco-training and Tamworth 2, so 1 second. Okay, so I got it. So here we go. Okay, so that looks correct. So if you have any questions, feel free to leave them in the comment section below. Bye.